method itself says it is half reaction method or ion electron method, right? So what we are going to do in the next step is we are going to split it into two different reactions. That means one will be the oxidation half reaction and the other one will be reduction half reaction, right? So now to balance the number of electrons in oxidation half reaction and reduction half reaction, you have to multiply the oxidation half reaction by 6. So I'm going to add 4H2O here. Again, to balance this 4H2O, the exact number of OH minus I am going to add on this side. So this is the way in which we have to balance this. Hello everyone, this is Ambli Unnikrishnan from the Department of Chemistry, Vidhyaashram Pre-University College, the Temple of Excellence, Mysore. So in the last session, we discussed about balancing of oxidation reduction reactions, right? So in detail, we discussed about the oxidation number method. So in today's session, we are going to study about half reaction method or ion electron method, right? And also the applications of redox reactions, okay? So in the last session, we only discussed about the balancing of redox reactions in acidic medium. So in today's session, we will be discussing in the basic medium also, that is the oxidation number method as well as the ion electron method, okay? So let's see the method for balancing redox reactions by ion electron method was developed by Jette and Lamev in 1927. So the next method we are going to study. So the steps that we have to follow to balance the redox reactions are quite similar with what we have studied in oxidation number method itself. Okay. So let's see. For the given skeleton equation, assign oxidation numbers to the atoms in the equation and find out which atoms are undergoing oxidation and reduction. So that is the same step that we have done in the other method also. First we have to write the skeletal equation, right? And then we have to assign the oxidation numbers based on the rule which we have already studied, right? So once we assign the oxidation number, we have to identify which atom is undergoing oxidation and reduction, right? And the next step is split the redox reaction into two half reactions. So the method itself says it is half reaction method or ion electron method, right? So what we are going to do in the next step is we are going to split it into two different reactions. That means one will be the oxidation half reaction and the other one will be reduction half reaction, right? Okay. Then balance the atoms other than hydrogen and oxygen for each half reaction using simple multiples. Okay. So the next step is also quite similar. We have to balance the atoms other than oxygen and hydrogen atoms by using the suitable multiples, right? Suitable integers we have to use to multiply so that the number of atoms will be equal on both the oxidation half reaction as well as the reduction half reaction. Now, remove the electrons from the oxidation half reaction and add the electrons to the reduction half reaction. As the name suggests, it is ion electron method, right? So, in oxidation reaction, what is happening? There will be loss of electrons, and in reduction, there will be gain of electrons. So, we have to add and subtract those number of electrons in that reaction. Okay, so now multiply the oxidation equation by added electrons of reduction half reaction and the reduction equation by removed electrons of oxidation half reaction so that the number of electrons become equal in both the half reactions. So the next step is to make the number of electrons same on the oxidation half reaction as well as the reduction half reaction, right? So the number of electrons which is associated in the oxidation and reduction, we have to use the suitable multiples or suitable integers so that the number of electrons will also become the same, right? Now the next one is balance hydrogen and oxygen atoms by water molecules. This also we have done in the oxidation number method, adding the suitable number of molecules of water, right? Yes, now there comes two criteria, that is whether it is in acidic medium or basic medium. So in acidic medium we have already studied on whichever side there is the deficiency of oxygen atom, we need to add the suitable number of molecules of water, and on the other side the appropriate number of H plus ion molecules are supposed to be added, right? So let's see, first in the acidic medium, first balance oxygen atoms by adding water molecules to whatever side deficient in oxygen atoms, and then balance hydrogen atoms by adding H plus ions to whichever side which is deficient in hydrogen atoms. So this we have already done in the last session, right? And for basic medium, what we have to do, again the first step is the same. When in whichever side oxygen atoms is less, we have to add water molecules there. And then how many hydrogen atoms is required? That much number of molecules of water is again to be added on the other side. So instead of H plus ions, adding H plus ions, we are going to add water molecules itself. Right, and to balance that, the exact number of OH minus ions is also added on the other side. So this might be a little confusing when you read this, but once we do the problems, it will be clear for you. So let's see, first balance oxygen atoms by adding water molecules is the same. Whichever deficient in oxygen atoms, the hydrogen atoms are then balanced by adding water molecules. Okay, we are adding water itself, not H plus ions, equal in number to the deficiency of hydrogen atoms. And an equal number of OH minus ions are added to the opposite side of the reaction. So this is the steps. Now let's take a problem. Balance the following redox reaction by half reaction method. So we are going to follow the half reaction method. So the reaction is already given to you. So the first step is to write the skeletal equation. So it's already skeletal equation itself which is given. Now we have to assign the oxidation numbers in the next step. So Fe2 plus Cr2O7 2 minus gives Fe3 plus and Cr3 plus. So here Fe2 plus, Fe3 plus and Cr3 plus are ions. So the oxidation number is the charge itself, right? So it is plus 2 here, plus 3 here and plus 3 here. For Cr2O7 2 minus, we can calculate Cr2O7 2 minus. So it is 2x plus 7 into minus 2. For oxygen it is minus 2, right? Which will be equal to minus 2, which is the charge, right? So 2x minus 14 will be equal to minus 2, 2x will be equal to 12, x will be equal to plus 6, right? So that is the oxidation number here. So assigning of oxidation number is done. Now the next step is to identify which is undergoing oxidation and reduction. So iron from plus 2 state, it has increased to plus 3 state. The oxidation number has increased from plus 2 to plus 3. So oxidation number increasing means it is oxidation, right? Now for chromium from plus 6 it has reduced to plus 3. So it is undergoing reduction. So the step 2 is also done, right? Now the next step, separate the equation into two half reactions. So now we are going to split the reaction into two half reactions. One is oxidation half reaction, the other one is reduction half reaction. So Fe2 plus getting oxidized to Fe3 plus, that is the oxidation half reaction, right? So that is what is shown here. And the reduction half reaction Cr2O7 2 minus to Cr3 plus, right? Now the next step is balance the atoms other than oxygen and hydrogen in each half reaction individually. So other than oxygen and hydrogen atoms we are going to balance, okay? So Fe2 plus to Fe3 plus, it is getting oxidized. So the number of atoms of iron is same on both sides. So there is nothing to balance here. But in the next case, that is reduction half cell, Cr2O7 2 minus to Cr3 plus it is, right? Cr2O7 2 minus to Cr3 plus. So now in this case, as you can see on the reactant sides, there are 2 atoms of chromium and on the product side only 1. So what do we have to do? We have to multiply it by 2, right? So that is what is shown here, 2 Cr3 plus. Okay. So now balancing of other atoms other than oxygen and hydrogen is done, right? Only 1 atom of iron here, 1 atom of iron here, 2 atoms of chromium here, 2 atoms of chromium here. So now moving on to the next step. For reactions occurring in acidic medium, add water molecules to balance oxygen atoms and add H plus to balance hydrogen atoms. Okay. So it's given that it is in acidic medium. So we have to add the appropriate number of molecules of water, and to balance that on the other side, we have to add the appropriate number of H plus ions as well. So let's see, it is given Fe2 plus to Fe3 plus, right? On the reactant side, you have Fe2 plus and Cr2O7 2 minus. We are going to combine both of the equations. So Fe2 plus and Cr2O7 2 minus gives Fe3 plus and Cr3 plus. This is what the 2 Cr3 plus. This is what the equation is. So now we have to calculate the number of oxygens on either sides, right? So you have 7 atoms of oxygen here and you have no oxygen here as of now, right? So to balance the number of oxygen atoms, we have to add the required number of molecules of water on the side which is deficient in oxygen atom. So you can see there is no oxygen atoms here. So we add 7 molecules of water, right? So that you will get 7 oxygen. Now we have to balance the number of hydrogen atoms, right? So how many hydrogen atoms? 7 into 2 will be there, 14, right? So that many H plus ions to be added on the other side. So that is done, right? Now add electrons in respective side of the half reactions to balance the charges. Thus, oxidation and reduction half reactions are written to balance the charges as. So, let's see. Now, we have to write the number of electrons also associated with this, because it is ion electron method, right? So, when Fe2 plus is getting oxidized to Fe3 plus, that is from plus 2 oxidation number to plus 3 oxidation number, how many electrons are being released? Right, 1 electron is being lost, that is oxidation has taken place. Now, Cr2O7 minus to 2Cr3 plus, that is here the oxidation number is plus 6, here the oxidation number is plus 3. That means oxidation number is increased by 3, or else there are 3 electrons which is associated. But that is for 1 atom of chromium. But you have 2 atoms of chromium here. So that is 6 electrons which is being accepted. So that you get 2Cr3 plus. So it will be 3 into 2. Right. It is plus 6 to plus 3. That means 3 electron is being accepted. But still there are, that is for 1 atom of chromium. But you have 2 here. So that is 3 into 2. Okay, so that is 6 electron. So 14H plus and 7H2O, it is already, we have balanced, right? Now to equalize the number of electrons in both half reactions, multiply the oxidation half reaction by 6. Okay, so here you can see only 1 electron. Right, and here you can see there are 6 electrons. So now to balance the number of electrons in oxidation half reaction and reduction half reaction, you have to multiply the oxidation half reaction by 6, right? So that the number of electrons will be same, 6 electrons here and 6 electrons here, right? So we will get 6 Fe2 plus gives 6 Fe3 plus and 6 electron. So now what happened? The number of electrons is also same, right? Now add the 2 half reactions to get the overall reaction and cancel the electrons on each side. That means if we are going to add these 2 reactions, that is this one and this one, if we are going to add, you can see 6 electrons on the product side here and 6 electron on the reactant side here. So if you are adding these 2 reactions, this 2 will get cancelled. Now whatever is left, you can combine it and write, that will be your final balanced redox chemical equation. So 6 Fe2 plus, right, you have the 6 Fe2 plus here, Cr2O7 minus and 14H plus ions gives 6 Fe3 plus, right, again it is 6 Fe3 plus and 2 Cr3 plus and 7 H2O. So this is the balanced redox reaction. So I hope it is clear in acidic medium how you are supposed to do this. Now let's take an example in basic medium how we are going to do the redox reaction by half reaction method. So permanganate ion MnO4 minus in basic solution oxidizes iodide ion to produce molecular iodine and manganese oxide. Write a balanced ionic equation to represent this redox reaction. So we have to write the appropriate equation and then we are going to balance it. So first we write the skeletal equation, that is MnO4 minus plus I minus gives MnO2 and I2, and it is given that it is in basic medium. So the first few steps will be the same, then we have a small change in the procedure that we are going to, or the steps that we have to follow. Okay, so this is the skeletal equation which is written down here. Now we have to identify the oxidation and reduction, which atoms are undergoing oxidation and reduction. So for that MnO4 minus, let's calculate the oxidation number. So it is X plus 4 into minus 2 is equal to minus 1, X minus 8 is equal to minus 1, X is equal to plus 7. So here manganese is in plus 7 oxidation state, iodine it is minus 1, right? And MnO2, let's calculate for MnO2 also. It is X plus 2 into minus 2 is equal to 0. So X minus 4 is equal to 0, X will be equal to plus 4. So manganese here it is plus 4 and iodine will be 0 as it is in its elementary state. So what happens from manganese plus 7 to plus 4, it has reduced. So it is undergoing reduction, and iodine minus 1 it has increased to 0. So that means it has undergone oxidation. So we identified the oxidation and reduction half reaction, right? So the oxidation half reaction is I minus getting converted into I2, that is minus 1 to 0 oxidation number has increased. Now the reduction half reaction is MnO4 minus to MnO2, that is from plus 7 it has reduced to plus 4. Okay, so till here I hope it is clear. Now to balance the iodine atoms in the oxidation half reaction, what do we have to do? Now the next step is to balance the other atoms other than oxygen and hydrogen. So in this case you can see 1 atom of iodine and 2 atoms of iodine here. So what do we have to do? We have to multiply this by 2, right? So that means 2I minus will give I2. So we multiply by the 2. So I hope that is clear. So here you have only one atom of manganese and one atom of manganese. Okay. So there is no need to multiply with anything in the reduction half reaction. So the iodine is balanced here and the manganese is also balanced here. Right. Now the next step is to balance the oxygen atom in the reduction half reaction. Add 2 water molecules on the right. Okay. So you have MnO4 minus which is giving MnO2. So here you have 4 atoms of oxygen. You have 2 atoms of oxygen. So to balance this, you need to add 2 atoms of oxygen here, right? So that means you have to add 2 molecules of water. So you add 2 molecules of water here. So that is the first step. Now, if it was an acidic medium, what you are supposed to do? You are supposed to add, that is 2 into 2, 4H plus ions here. But this is in basic medium. So there is a slight change. So let's see, as a reaction takes place in basic solution, therefore add 4 H2O molecules to the equation. So that means that you have MnO4 minus which is giving MnO2 and 2 H2O. Now the number of atoms of oxygen is balanced, but number of hydrogen atoms also needs to be balanced. So how many hydrogen atoms are here? 2 into 2, 4 atoms of hydrogen. So to balance that in acidic medium, we add 4H plus ions. But in basic medium, that number of hydrogen atoms we are going to add in form of water molecules itself. That means 2 into 2, 4 molecules of water we are going to add on the other side. So that is what is shown here, MnO4 minus plus 4H2O. We added 2 H2O here in the beginning, right? So 2 into 2, 4 H2O we are going to add here. Again, the number of hydrogen and oxygen will be not balanced. So the exact number, how many molecules of water we are going to add, the exact number of OH minus we are supposed to add on this side. Okay, on the other side. So this is the step in basic medium. Now we can see 2H2O here on the product side and 4H2O here. So this will cancel out and you can get 2H2O here on the reactant side. 4H2O and 2H2O, that will be 2H2O. So this is the last equation, MnO4 minus plus 2H2O gives MnO2 and 4OH minus. So I hope till here it is clear. Now moving on to the last step. In this step, balance the charges of the 2 half reaction in the manner depicted as. So you can see now it is ion electron method, right? In terms of electron we have to write. So it was 2I minus which is giving I2. So that means 2I minus it's getting oxidized to I2 means how many electrons are being lost, right? 2 electrons. And in MnO4 plus 2H2O, that is, it is getting converted into MnO2. MnO4 minus getting reduced to MnO2. How many electrons are associated? It is from +7 to +4 oxidation number, right? Oxidation state. We have written that in the beginning itself. That means 3 electrons are associated here, right? And it gives 4OH minus ion, which is already written here. Okay. So you can see here 2 electrons here and 3 electrons here. Now, again, what is the next step? We have to balance the number of electrons as well. So that means we have to multiply this particular equation by 3, right? And we are going to multiply this particular equation by 2. So it is 3 into 2 you will get 6 and here also 2 into 3 you will get 6. So that means the number of electrons we can make it equal. So that is what we are going to do. Now to equalize the number of electrons, multiply the oxidation half reaction by 3 and the reduction half reaction by 2. I hope it is clear. So it becomes 6I minus gives 3I2 plus 6 electron and 2MnO4 minus plus 4H2O plus 6 electrons gives MnO2 and 8OH minus. So it's this what I have explained. This reaction if you multiply by 3 you are going to get this one. And this reaction if you are going to multiply by 2, that means each term you are going to, or each of the reactants and products you are going to multiply by this number. So you are going to get this. So I hope it is clear. Now we are going to add 2 half reactions to obtain the net reaction after cancelling the electrons on both sides. So you can see the 6 electrons are on the product side here and 6 electrons on the reactant side here. So these two will get cancelled. Now we are going to add both of the reactions. So you get 6I minus plus 2MnO4 minus. And what is left here on the reactant side? 4H2O, which gives 3I2, 2MnO2, which is on the product side, and 8OH minus. So that's it. So this is the final equation. So if you count the number of atoms on both of the sides, the oxygen, hydrogen atoms and all other atoms will be balanced. So this is the final balanced redox equation in case of basic medium. So I hope it is clear. Now let's do one more last problem based on this. Balance the following equation by ion electron method in basic medium. So the equation is already given to you. So the first step, assign the oxidation number, identify which is undergoing oxidation and reduction. MnO4 minus plus Br minus gives MnO2 and BrO3 minus. So this is the equation. So if you calculate the oxidation number, it will be plus 7 here. Br minus, it will be minus 1. MnO2, it is plus 4. We have already discussed this in the previous example, right? And BrO3 minus, if you have to calculate it, BrO3 minus x plus 3 into minus 2 is equal to minus 1. X minus 6 is equal to minus 1. X is equal to plus 5. Right. So that is what is shown here. So the oxidation number we have calculated. So that means manganese from plus 7, it has reduced to plus 4. So that means reduction half reaction is that one. And bromine from minus 1, it has increased to plus 5. So that is undergoing oxidation. So that is what is represented here. So that part is also clear. Now the next step is to write it into two half reactions, oxidation half reaction and reduction half reaction, right? So MnO4 minus getting reduced to MnO2, that is the reduction half reaction, that is plus 7 to plus 4, right? And Br minus is getting oxidized into BrO3 minus, which is the oxidation half reaction, that is minus 1 to plus 5. So this much is done. Now, the next step is MnO4, the two reactions we have written separately. MnO4 minus getting converted into MnO2 and Br minus is oxidized to BrO3 minus. So, now the electrons associated with the oxidation and reduction, we are going to represent it. So, MnO4 minus, it is getting converted into MnO2. That is, it is reduced to MnO2. That means plus 7 to plus 4 means how many electrons are being accepted here? Yes, there is a gain of 3 electrons which is represented. Now, Br minus, that is minus 1 to plus 5 means how many electrons? That is 6 electrons. So, 3 electrons in the reduction half reaction and 6 electrons in the oxidation half reaction, right? So, now that part is done. So, the next step is to balance the number of atoms other than oxygen and hydrogen. So here manganese is 1 and manganese is 1. The number of atoms is same. Here also 1 atom of bromine, 1 atom of bromine. So there is no problem in that case. Now we have to balance the number of oxygen atoms. So let's write down the reduction half reaction first. That is MnO4 minus plus 3 electron gives MnO2. Right. So this is the reduction half reaction. So you have 4 atoms of oxygen here and 2 atoms of oxygen here. So to balance that, we are going to add 2 molecules of water here. So if I add 2 molecules of water here in basic medium, the required amount or required number of hydrogen atoms we are going to add in form of water molecule itself. So 2 into 2 it is 4. So I am going to add 4H2O here. Again to balance this 4H2O, the exact number of OH minus I am going to add on this side. So this is the way in which we have to balance this. So now what happens is this 2H2O and 4H2O gets cancelled and you will get 2H2O here. So that is what is you can see in this reaction. MnO4 minus plus 3 electron plus 2H2O gives MnO2 and 4OH minus. So this is in the case of reduction half reaction. Now oxidation half reaction, if we are considering, it is Br minus gives BrO3 minus plus 6 electron. Now in this case you don't have any oxygen atom here, but you have 3 oxygen atom here. So that means how many molecules of water you have to add on this side? 3 molecules of water. So 3 molecules of water means how many water molecules on the other side now? That is 3 into 2, 6 you have to add, 6H2O. Now the exact number of OH minus we have to add on this side as well. So this 3H2O and 6H2O you will get 3H2O here. So that is what is shown here. Br minus plus 6OH minus gives BrO3 minus 6 electron and 3H2O. So till here I hope it is clear, right? So once we balance the other atoms, we have to balance the number of oxygen and hydrogen atom. As it is in the basic medium, we are doing it in this form. If it was acidic medium, you just have to add the appropriate number of H plus ions. But in basic medium, you have to add it in the form of water molecules itself. And the exact number of water molecules that you have added, that exact number of OH minus you have to add on the other side. Okay, so this is the reaction you are getting. Now what we have to do, you can see here 3 electrons and 2 electrons in this case. So now we have to, the next step is to balance the number of electrons. So in the reduction half reaction, you can see 3 electrons. And the oxidation half reaction, you can see 6 electrons. So how can you balance this particular equation? That is the reduction half reaction. If you multiply by 2, the number of electrons will be same, right? So that is MnO4 minus plus 3 electron plus 2H2 gives MnO2 plus 4OH minus. This particular reaction we are multiplying by 2, and this equation we keep it as it is. So what happens? The number of electrons, 3 into 2 will be 6 here. So this 6 electron, 3 into 2, the whole reaction we are multiplying by 2, right? So this 6 electron and this is 6 electron will get cancelled. So now the rest of it we are going to join together or add together and write. So into 2 means 2 MnO4, which is shown here, 2 MnO4 minus plus Br minus plus H2O. So where did this H2O come from? 2 into 2 will give you 4H2O, right? 2 into 2 will give you 4H2O. And on the product side, you have 3H2O. So this 4H2O and 3H2O will cancel and you will get just one molecule of water. So I hope it is clear. Now coming to the product side. Again, 2 into MnO2 will give you 2 MnO2. Then you have BrO3 minus and you have 2 OH minus, which is left here. That is here, from here you will get 8 OH minus. That is 4 into 2, 8. And here you have 6 OH minus. So 8 OH minus and 6 OH minus will cancel and you will get 2 OH minus. So I hope it is clear. So this is how you have to balance the redox reaction in basic medium. So I hope the steps is also clear for you. So now moving on to the last part, that is applications of redox reactions. Okay. So the first one is redox reactions as the basis for titrations. So in your second year, you will be doing titrations, which is based on the redox reactions. In redox system, titration method can be adopted to determine the strength of the reducing agent and oxidizing agent using redox indicators. The use of indicators during redox reactions can be illustrated as follows. There is self-indicator method as well as internal indicator method. Now the next one is electrode process in redox reactions. When a metal rod is dipped in a solution containing its own ions, equilibrium is established between metal and the metal ions of the solution. Due to this equilibrium, a potential is developed by the metal with respect to the solution. This potential is called single electrode potential or potential of the half cell. So this also in detail you are going to study in your second year in the chapter electrochemistry. So that means that, for example, if we are taking zinc sulfate solution here, zinc sulfate solution, and we are going to dip a rod of zinc which is made of the same metal, right? Zinc we are going to dip in zinc sulfate. What happens is redox reaction will take place, oxidation and reduction will take place, and what happens is there will be a potential which will be developed between the electrolyte and the electrode. Okay, so here also the application is based on what? It is based on redox reaction, right? So what does this mean? For example, let's take 1/2 cell, that is zinc sulfate electrolyte we have taken, and zinc rod is dipped here, and on the other half cell you have copper sulfate electrolyte which is on which or into which copper rod is dipped, and now we can connect it through a wire and attach a voltmeter. So now what does this mean is in detail you are going to study in the second year in electrochemistry chapter. So what happens here is in zinc electrode oxidation reaction will take place, and in copper reduction reaction will take place. That is, this is where oxidation is taking place, that will be your anode, and where reduction is taking place, that will be your cathode. So in anode what happens is zinc gets oxidized to Zn2 plus by releasing 2 electrons, and in the cathode copper 2 plus ions will accept these 2 electrons and forms copper. So this is what is happening, oxidation and reduction will take place. That is why simultaneously it is taking place, so it is a redox reaction, right? So because of this oxidation and reduction taking place, there will be a potential which is developed. So as you can see in the anode, the electrode where oxidation occurs. In anode what happens? Oxidation occurs, and anions are attached to it, connected to the positive end of battery in an electrolytic cell, okay, and loses weight in electrolytic cell. Why it loses the weight means, as this reaction is proceeding, what happens is the size of this electron keeps reducing because it is getting oxidized, right? It is losing its electrons, it is getting oxidized. Then what happens to the size of copper, which is acting as the cathode? It is accepting these electrons, and copper is getting deposited on the copper rod. So what happens? The size of this electrode will increase. Now in cathode electrode where reduction occurs, right? And cations are attracted to it. connected to the negative end of the battery in an electrolytic cell, and it gains weight in electrolytic cell. That means its size increases. So these are the applications of redox reaction. So that is titration and in the electrolytic cell. So by this we come to an end to this chapter. So I hope the concepts that we have covered in this whole chapter is clear for you. So let's meet in the next session with a new chapter. So that's all for today. Thank you.